Hello everyone and welcome to yet another recreational programming session with Mr. Zozi. So I was going through my old stuff and I found a notebook that I bought long time ago, I think 10 years ago, and I never really used it, so it's primarily blank. Right, so except first two pages. On the first two pages, I have some stuff written in. So on the first page, there is a quote in Russian, for whatever reason, by Bertrand Russell, and it's in Russian, but I can try to translate it. So it says, probability is the most important notion in a modern science, especially because absolutely nobody has any idea what it means, right? So that's how it's spelled, right? So it's spelled in Russian cursive, and apparently, like, I really liked that quote, so I put it in here as the first thing for my notebook that I never freaking used. Right. So, and the second thing in here is kind of bizarre. There's some sort of like a pattern in here. Like, what the fuck is that? So let's actually made a screenshot of this entire thing and try to super quickly understand that. So I want to super quickly make a screenshot. OBS, as far as I know, lets me make screenshots. Right. So, and let's actually switch to this thing. Let me go in here, and yeah, so here is the screenshot that I have in here. So there's some sort of a pattern in here, which is kind of bizarre, right? So, but if you look at that, it kind of overextends to the right, and it's aligned by sort of like 6 elements, right? So it probably goes top to bottom, left to right. And it's a sequence, apparently it is a sequence of 6-bit numbers. So it looks like I encoded some sort of a message in here, right? So, and this is actually super common for me because this is what I do quite often with all of my notebooks. So I like to put some sort of like a, encrypted Easter eggs of some sort, right? So if I lose that notebook and it will be found by somebody, right? So, and that somebody is some sort of like a fellow hacker, right, or software developer, they will manage to decode that. For instance, here is the notebook that I actively use, right? So these days, and at the beginning, it has a field for an email, right? So, and my email there looks like this. So it's literally base 64, right? I literally wrote down base 64. So if I lose it, right, so somebody finds it. So, and if you're a software developer, you instantly recognize that this is base 64. So you'll type it down and you will get this kind of thing. So it's just like I like to put this kind of Easter eggs into my notebooks and stuff like that. And I use them for different kind of stuff, right? I usually write down notes or different doodles. I like to draw, right? So I like to draw these kind of things. So, and I have a lot of different notebooks like lying around. So there's a lot of shit going on in my brain, so I need to actually put it down somewhere, right? So, and this looks like one of these cases, right? So it looks like one of these cases when I encoded some sort of like an Easter egg in here, and I could actually like manually, painstakingly sort of try to like retype it into the computer and try to decode it and stuff like that. But I thought, what if I actually write a program like that uses computer vision to extract those bits and turn them into a readable message? So, and it looks actually kind of not really that difficult. So essentially it's just a grid. But as you can see, if I just take a photo, right, so this is like a very skewed and warped grid. So we'll have to come up with some sort of an algorithm that allows us to iterate the grid that is warped like that, right? So I have an idea of actually creating a tool that allows me to visually put the corners of this rectangle, right? So I'm gonna denote, okay, so this corner goes here, this corner goes here, and this one goes here and here, right? And that way, I will be able to know how much it is warped, and using linear interpolation, I will be able to actually iterate precisely all of these skewed cells of the grid, right? So, and maybe then I can apply a bunch of filters on this image, maybe so turn it black and white, or maybe then apply like a Sobel filter, right? So the edge detection, and essentially sample each individual cell, right? And since it's going to be like, for example, edge detection, so there will be some sort of a value, and if it passes some sort of threshold, we can assume that the cell is sort of filled in, right? We'll figure it out. So that's basically the idea that I have for today's stream. Right, so, and yeah, that's what we're gonna be doing. Sounds good? Sounds Gucci? Sounds at Tamaguchi. We're gonna be decoding a message from the past, right? Because I think it's from 10 years ago. At least on the back, it says that it was made in 2010. So, like, I bought it probably like very long time ago. I think it's made in 2010 in Moscow specifically, right? So I don't freaking know. So yeah, sounds cool, sounds interesting, I think. Let's go and create the project. I think I'm gonna actually make this tool as part of Panim, right? And Panim is a programming animation engine that I developed for my YouTube videos, right? So it's kind of similar to Manim, which 3Blue1Brown uses for his animations. And the reason why I want to do it as a plugin for Panim is because I don't have to set up anything, right? So I already just have the project that already uses Raylib and stuff like that. And I also have a hot reloading, right? So which will help me to easily iterate through all of that stuff. So I think it's a pretty interesting idea. So you know what I noticed is that, so Panim is very useful not only as a programming animation engine. It's useful not only for making animations. It's useful as a general purpose tool for just experimenting with graphical things and stuff like that. So it's useful as a sort of platform, even though like it's very simple. There's not that much code of the engine itself, but just the presence of hot reloading makes it incredibly useful, right? So I didn't really expect that. So anyway, so let's actually take a look. In Panim itself, we have a template, which is basically an empty plugin, right? So, and if we rebuild the whole thing, I think everything is already rebuilt, right? And we can try to run build Panim, build lib template, right? So this is how it looks like. So here is the template. It doesn't really do anything except saying Panim template. So what I want to do in here now, I'm gonna take the template and I'm gonna copy paste it and create a secret.c file, right? So, and maybe I'm gonna replace Panim with secret, so it's gonna be a different message. And then I'm going to add secret to the build. So it should be relatively straightforward, right? So I'm going to just replace this thing with secret, like so, and then I'm gonna rebuild this entire stuff. Okay, so then I'm gonna try to run secret, like so, and as you can see, it says secret template. So that's what it does. So the first thing we probably want to do, we want to load the screenshot into the tool, right? So I'm gonna take the screenshot to like from here somewhere, and I'm gonna put it probably into the assets, right? So where is this entire stuff? Just a second. Let's go into the assets. So we have images in here, and I'm gonna literally move this entire thing in here. So here's the screenshot. And now if I go here in a secret, we have a function for loading the assets. I'm gonna assume that this image specifically is gonna be sort of like an asset, right? So it is located in assets, images, like so. And we're gonna add an image as a part of the plugin. So honestly, image, if I load it as an image, it will load it into CPU. So in Raylib, there is no way to render an image, right? So to just draw an image, right? So I can do something like image. I can say load image, and that should be it, right? So it's as simple as that. So if I try to reload this entire thing, yeah. So if I take a look at the Raylib, include raylib.h, draw image. You can't really draw an image, right? So there's no such thing. So you can only draw a texture, right? So what we could have done, we could have loaded texture from file, but I think we'll still need an image because we want to be able to modify image pixels, right? So image is image on the CPU. So, and when you have an image, you have a direct access to its pixels. Texture is the same image, but on GPU. Right, so and you can't really access its pixels directly, but you can render it. So you kind of need to actually have both of them, right? So you need both image and the texture. So, but you can actually create texture from the image. So maybe this is something that we want to do in here. So I'm going to create a texture, 2D texture, right? So, and in here, I'm going to say, okay, so texture, texture, load texture from image. And that's the image that we have in here. Okay, so once we load the assets, we also need to implement some code that unloads the assets, right? Because every time you hot reload the plugin, it actually unloads the assets and loads them back, right? So it constantly hot reloads the assets as well along with the code. So it's really important. So let's unload an image, p image, right? And let's also unload the texture, p texture. There we go. So let me try to rebuild this entire thing, and I'm going to try to hot reload this entire stuff. So we can't really see anything, but it should be reflected in the logs. And in the logs, we can clearly see that screenshot, blah, 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 file loaded successfully. So it successfully loaded that image. So the next thing we probably want to do, we want to actually try to render that image somehow. All right, so if I go into the ray lib, I should find draw texture. So yeah, we're going to use the version that accepts the vector, right? So we're going to be doing that instead of the text rendering. So let's actually remove all of the text rendering. I don't think it's important. So the position is going to be 0, 0. So the texture that we're rendering in here is this one. The position is just 0, and the tint, right, is going to be white. So for some reason, Raylib allows you to add a little bit of a tint into the rendered texture. So usually if you don't want to have any tint, it's going to be basically white, right? And there we go. If we hot reload, so here is basically the image, but it's actually like offset, right? It's offset a little bit. So maybe one of the things we want to do, we want to actually take a position and say that it's like half of the size of the texture. Does the texture, by the way, has width and it does in fact have width and height? Look at that. So we do have width and height. So we can take the texture like so, and we can take a width, and maybe we can multiply it by -half, right? And then we can take and do height, not really height maps, height multiplied by -half, like so, right? So if I could reload this entire thing, and then I do H, and as you can see, it's actually centered. So one of the things I want to be able to do, right, with this tool, I want to be able to drag around and maybe zoom in and zoom out, right? So we need to be able to zoom in and zoom out. So maybe zooming in is easier to implement, right? Because you just like modify this particular parameter in here. So let's go ahead and maybe add zoom into the plugin state, right? So initially, when I do plugin reset, I think one of the things we want to do, we want to say zoom equal to 1, right? And essentially here we're going to be just using zoom from the plugin state. So we need to find how we get the wheel, right? So get mouse wheel. Okay, so we do have a get mouse wheel. Get mouse wheel movement for X and Y, whichever is larger. So if I remember correctly, it actually returns negative and positive values, right, depending on the direction where you're scrolling, right? So I think we can just like look at the sign of the direction. So maybe somewhere here, right? So let's save it into a separate variable like wheel, and if wheel is less than 0, we are going to take the zoom, and let's say we're gonna decrement it, right? So we're gonna decrement it by maybe like, you know, tenths, right? Then if it's greater than 0, we're going to increment it like so. And let's see if it's going to actually allow us to zoom stuff. Okay, so I need to, yeah, it actually, all right. I can actually zoom now, all right? So I think it's kind of important because I want to be able to like outline the boundaries of this entire thing, and I will need to be able to like zoom around and just drag as well. So yeah, so image viewer, we already have like a very simple image viewer, right? So which is kind of cool, which is kind of cool. So just a second. So we need to wait a little bit until all of these people actually like leave the stream, and then we can enable it back. So, all right. So how are we going to be dragging around? So when I hold the button, like the left mouse button down, right, I probably have to switch to some sort of like a different mode, right? So we need to switch to a different mode. And that mode is going to be indicated maybe by a Boolean variable, right? So let's say dragging. And to be fair, when I'm dragging around, so usually, how do we indicate the position of the camera? How do we indicate the position of the camera? The position of the camera is actually indicated by the target of the camera, right? So it's a target of the camera. Yeah. So there's also target it looks at. There's also position. Oh, it's a camera 3D. Okay, so I need the camera 2D. Right, it's kind of weird. So yeah. So we use offset to center it at the screen, so we probably don't want to mess with the offset. So the only thing we need in here is the target, right? So that's the actual position of the camera, right? So, and I can even try to play with the target. So if I, for instance, say that the target is going to be 100, right? So it's probably going to move it horizontally somewhere, but I'm not really sure where it's going to move it, like a left or right. Right, so let's actually go ahead and see. So it's complaining about something. I forgot a comma. Okay, so that's pretty cool. Right, so okay, so it moved it actually to the left, right? So that's basically what we have to use to keep track of the position of the camera and stuff like that. So maybe yeah, so we have a dragging, and because of that, we also need something like target, right? So this is the target. When I reset the state of the plugin, I suppose I want to actually say that this thing is going to be 0. And I wonder if I can just do, maybe I can just do mem set. Oh, if it's 0, yeah, we're mem setting this entire thing anyway, so maybe it doesn't matter. So I'm not really sure. But maybe it makes sense to actually just set it to 0 just in case. Let's just do it just in case. Right, so, and where is the zoom? So here what we have to do the target. Might as well actually copy paste this line and just replace the zoom with target. Right, so we have a zoom and a target. All right, so how are we going to be doing all of that? So we need to keep, we need to wait for certain events, right? So like, for example, mouse went down, mouse button was pressed, and mouse button was released. And it all kind of depends on the current dragging state, so to speak, right? So if we are currently in a dragging state, right, and is mouse button was released, we actually no longer in the dragging state, right? So is mouse button released? And I think you have to specify which button. Mouse button left, right? So it was released. That means we are no longer in a dragging state. So that's basically what's going on. All right, so, and now if you are not in a dragging state, if the mouse button was pressed, we're going into the dragging state. So that's basically what we need to do in here, right? So we're dragging state, we release it, we switch back. So, and maybe we want to actually sort of like test whether that is going to work, right? So for example, if we are in a dragging state, I said dragging state, let's draw a circle, draw circle. Do we have a draw circle V? Right, so we want to work with vectors and stuff like that. So let's actually, where we want to draw that? I suppose we want to draw that at the mouse position, right? So get mouse position, and the radius is going to be, let's say, maybe 10, and the color is going to be something like red, right? So it's going to be something like red. All right, so I'm going to hot reload this entire thing, and it doesn't really work. I wonder, oh, okay, so it does work, but it's offset. Okay, so because the mouse position is not at the world's position, it's at the screen. So you can already kind of see that, right? So you see it's like near my camera, right? So it is near my camera, right? So one of the things we need to do, we need to actually map the mouse position into the world, right? I remember that Raylip had something related to world. Yeah, get world to screen, or maybe get screen to world, right? So this is what we need. We need a function that takes the screen coordinates and converts them to the world given the camera, right? So given the specific camera, and that's probably the function that we need. So lagging, probably need to set FPS. Are we lagging right now? Maybe we are lagging. Just a second. So do I set target FPS? I do set a target FPS. One thing that I haven't here is that I set MSAAA, right? So multi-assembly anti-aliasing, and it kind of makes everything a little bit slower. I may try to disable that, right? So let me try to do that, but that will require to restart the whole application, because so far we were actually hot reloading this entire thing, right? But now if I have to modify this kind of like window flags, I have to restart the entirety of the thing. Is it going to be faster? Maybe. I don't really know if it's actually faster. We'll see. All right, so what I was doing in here, I need to map this entire thing. So I need to map get mouse position, and I'm gonna be using the camera to map this entire thing. So hopefully it's gonna be rendering all of that in the right coordinates. Way too many arguments. What? So it was called get screen. Yeah. So that's what it is. Get screen to world. Get screen to world. All right. So I'm gonna hot reload this entire thing, and now, okay. So as you can see, it is following the the mouse, right? It is following the mouse. So to be fair, when we are entering the dragging state, we kind of need to remember at which point we clicked, so we know how much we have offset from the original position of the mouse. So we know how much we have to offset the camera. Right, so we need to somehow keep track of that. So let me find this kind of thing. So I suppose let's call this kind of point an anchor, right? So this is going to be an anchor, and we save the anchor as we enter the dragging mode, right? So we're going to say that the anchor is equal to the get mouse position. To be fair, I probably want to save this thing as a variable mouse, if that makes any sense, right? So let's maybe put it in here, right? So it's going to be vector2 mouse. So this is our mouse position, and the anchor is going to be mouse, right? So, and when I'm rendering this whole thing, let's actually render it not the mouse, but rather the anchor. Anchor. There we go. So if I hot reload this entire thing, and I start dragging, as you can see, it stays where we initially clicked it, right? So, right, so that's cool. And now, so that's a very interesting part. I can subtract the current mouse position from its saved anchor, right? So you can do vector2, maybe subtract, but I don't really know, like, what exactly do I have to subtract, honestly? What exactly do I have to subtract? Okay, so let's give it a try. I'm not really sure how I'm going to approach that, but I'm going to just take the mouse position. So here is the mouse position, and I'm subtracting an anchor from that, and that gives me the vector. And I suppose what I have to do is to just add, maybe set it to the target, so to speak. What if I just do add p target, right? So I'm adding that to the target, and I'm reassigning the target back, right? So is that going to work? I feel like it's not going to work, but we'll see, right? If I just do that, okay, so that definitely didn't work. I can reset the state. What if I subtract? Right, so what if I subtract this entire thing? Let's hot reload this entire thing, and that surprisingly worked. Okay, I can drag this around. Right, so I have like a proper viewer now. Look at that. I have a proper viewer. Isn't that cool? I think that's pretty cool. Right, so why did it work? It's kind of, yeah. It's kind of bizarre that it works, but apparently it works, but yeah, so. Yusu, right, so let's hot reload. Now I can just drag around and stuff like that. So, yeah. Now we need to probably introduce the nodes that are going to be denoting the boundaries of the image, right, that we're trying to sort of like parse or sort of speak. So how we're going to be calling them? Let's call them something like nodes. We're going to have exactly 4 of them. So we're going to store them as an array, I think, right? So nodes is going to be 4 of them. Right. So when we're doing plugin reset, I want to kind of initialize them with something, right? So nodes, this node is going to be probably at 0, 0, right? So let's say it's a 0, 0. Then this one is going to be going to the right, right? So this is going to be something like maybe 200, right? So the second one is going to be on the other end. So it's sort of like a triangle strip, if you know what I'm talking about. So it's more like a triangle strip. And when we're rendering this entire stuff, right, what we're going to be doing, we're going to be iterating through all of these things, right? So let's say knob array length, and so nodes plus I, and let's draw a circle V, circle V in here. So this is nodes I. The radius, let's say, is going to be 10, and the color is going to be red, right? So that's what we want to do in here. So it doesn't know about knob array because we never actually included knob in here. Let's include it. All right, let's hot reload this entire thing. And yeah, so we need to reset the state. There we go. So here are like sort of like the nodes. So this one starts at 0, 0. And so to be fair, the image position is centered, which makes it not particularly correct. I would like for the left top corner of the image to be at 0, 0, but 0, 0 is at the center, which makes it kind of inconvenient. So let's actually get rid of the centering that I introduced at the beginning, because I don't think it's going to be useful. Where did I do the centering? So, okay, so here's the centering, and I'm going to just say 0, right? So, yeah. There we go. So that's a little bit better. So as you can see, this entire thing starts at 0, right? So because I want the positions, the actual positions of these nodes to correspond with the coordinates on the image, right? Because we're going to be accessing pixels of the image by those coordinates. So because of that, offsetting things is not particularly great, right? So because of that, offsetting them is not particularly great. All right. So now I need to be able to modify the positions of the nodes, right? So that means I need to be able to drag them around, but I already have a code that drags around the image, which is not particularly convenient. So can I do something else? Maybe I can actually assign some sort of like keys on each individual node. For example, if I hold 1 and click left click somewhere, it will move exactly that node to that place, because right now I'm a little bit lazy to do the dragging around for this thing, because I mean, like, I have the boolean that keeps track of the dragging of the view. Now I need to introduce another boolean that keeps track of the dragging of the nodes and stuff. It's like it's a huge pain in the ass. Right mouse button, maybe a right mouse button would be better, right? So, but I don't freaking know, honestly. I don't freaking know. To be fair, like something like a right mouse button would have been better for the view, right? So if I do something like right, right, so this one is going to be something like right. So I'm going to replace it. So now, yeah, okay, so left one doesn't do anything, right one actually drags it around. So plus control click, it's not really about plus control click, honestly, but anyway. So let me see. So if, like, how can we check that the mouse is within the particular circle? So let's factor out the size of the node. Node radius, right? So node radius, and let's say that the node radius is going to be 10. So this is basically 10. And maybe since I already defining the constants, let's actually define node caller, right? So this is the caller and this is red. And so ray leap collision. Where is the check collision circles? Point circle. This is probably what we need in here, right? So because it checks whether a particular point, in our case, it's a mouse, intersects with a particular circle, which is the node, right? So the center of the node is in here, and the radius of the node is in here somewhere, like so, right? And if we are intersecting this entire thing, we can actually draw this entire thing with a different color. Let's say it's going to be yellow. Otherwise, it's going to be something like that. So it's going to be node color. So maybe let's get rid of the node color, right? Because I'm not really sure how exactly I'm going to be rendering all of that. All right, so let me see. What do we have in here? So I'm going to hot reload this entire stuff, and look at that. It actually highlights them properly. So, but so if I'm going to be moving them here, I'll have to, yeah, maybe that's fine. Okay, so we need to introduce another thing, maybe something like dragging node, right, and dragged node. This one is interesting. So we can actually get rid of the dragging node boolean. So in essentially, if you're not dragging anything, we're going to indicate that with -1, right? So, and if you're dragging something, there's going to be some sort of an index in here. Right, so maybe that's a good idea. So in the plug reset, we're going to be saying that the dragged node, right, the dragged node is going to be -1, and it indicates that it's not currently dragged or anything. So yeah, and now this is basically where we have to do all of that. So if p dragged node is less than 0, right, and it's less than 0, and you are intersecting some sort of a node in here, if some sort of a node here is intersect and is mouse button mouse button pressed, right, and specifically mouse button left. Honestly, like, all right, so it's too much. Like, I don't want to write all of that logic. It will be easier if I just held some sort of a key down and like left clicked and it would just modify. Like, I don't want to do that. That's stupid. That's dumb. Right, so because it's a throwaway code and I'm like spending like effort on that code, like it's gonna be some sort of a production shit. Right, it's just like it doesn't make any fucking sense, right? So this is the ultimate definition of just like a bike shitting, or not even bike shitting. It's just like I don't know why the fuck I'm doing that, right? So if is key pressed, for example, key, I don't know, P, right? So if I press, like maybe is key down, right? If is key down and is mouse button pressed, specifically mouse button left, I'm gonna be just literally taking the node that is like the first one, I'm gonna setting it to the mouse, right? So drag node, it does not exist anymore, right? So, and for instance, I can hold P. Am I holding P, by the way? I need to hot reload this entire thing. Yeah, there we go. It's easy. That's it. So it's just like, yeah. So maybe you know what? Maybe I don't even have to press while I'm holding that one. It's gonna be actually moving this entire thing. So Yeah, so I'm holding it and it's moving and I'm just like unpressing it and that's it. It's kind of done. Right, so you know what would be convenient if we just maybe used the keys 1, 2, 3. Right, so the key is 1, 2, 3. So does raylib, and you see, I'm already done. I already implemented modifying the position of the node without all this dragging around boolean. It's just like we don't have time for that. It's a throwaway code anyway. Right, it's a throwaway code anyway. Right, so key 1. Oh, okay, so key 1, I can use that. Can I say key 1 plus I? That's it. That's actually it, honestly. Huh. Maybe we can do the following thing. Right, so let's say selected. This entire thing is selected, and if you do is mouse button pressed, mouse button left, selected, and is mouse button pressed, we do that. So if selected, we do that. All right, so let's see. I'm holding 1, I'm holding 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4. I'm holding 1, left, 2, that, 3, that, 4, that. Okay, so let's actually set the first one. So this is the second one, right? So then this is the third one and the fourth one. Something like this. Yeah. Yeah. New UX has been discovered. Who needs drag and drop? Who needs drag and drop? The new UX has been just discovered. Right. So Cormac, with his act on press, act on release, is shaking and crying right now. Have you ever thought that you can drag around nodes just by holding 1 and left click and shit like that? I'm fucking telling you. This is a revolutionary UX. Drag and drop is for losers, and look at that, it's act on press. So it feels snappy, it feels responsive. Can your web do that? I don't fucking think so. I don't fucking think so. Sorry. Okay. Let me see. So I want to actually make the nodes a little bit smaller, right? So because I think they're too big. Right, so it's gonna be like a 5 pixels, and yeah, also actually how to reload them. There we go. So they're now pp small. Maybe another thing that I want to do in here, maybe I want to make them semi-transparent because they're too freaking solid for me, mate. Too freaking solid. So color alpha, right? So let's say the color alpha is gonna be maybe 75, and I kind of need to repeat that for all of these colors in here. So this one's going to be also 75. So let's make them slightly transparent. Yeah, as you can see, they are now kind of transparent, and you can see that thing. Hopefully. Right. So this is the second one, and oh, to be fair, okay. So this thing is actually extended a little bit. So that means the fourth one also has to be extended like a tiny bit like that. It has to be extended. All right. So to be fair, I want to be able to maybe save the state of the node somehow, because now if I restart the whole application, it's going to nuke this entire thing. It's literally going to nuke this entire thing. So let me see. So when I press some sort of a key somewhere, right, and again, I'm doing all of that within a single sort of like session, right? It's actually technically second session because I had to restart this entire thing, but it's a single session. So right, I'm modifying the application live, and the data that I'm generating in here could be lost. Actually, it actually could be lost. Right. Okay. So let me see. So if I is key pressed. So let's say key S. When I press this thing, like I want to save the state of the nodes somewhere. We can actually, we don't have to use text. We can just take the nodes and just dump them raw. Right, so we can just do that raw like I did your... So, and I wonder, we can just use fwrite, like fread and stuff like that. But I feel like Raylib had stuff like save... Yeah, save file date. Yeah, I remember that. So, yeah, you can just like a save file data you can load. Yeah. All right, so let's actually use that. Right, and let's put it in here. So let's save the state of the nodes as an asset. Right. So let's save it as an asset. So where are the assets? So we have different curves. So this is for the Bezier curves. So we have fonts, images, and stuff like that. So let's actually say this is going to be the data. So there will be like a folder called data. And what I'm going to do, we're going to say assets, data, nodes, bin. Right, so this is going to be nodes, bin. And I'm going to just take the nodes and then the size of the nodes. Right, so this is the size of the nodes. And that's it. So I'm just saving the whole thing. Now, if I rebuild this entire stuff and I hot reload this entire thing and I'm going to press S, let's take a look at the logs. Okay, so nodes.bin file saved successfully. So if I take a look at the assets and the data, here are the nodes, and so yeah, here is just the data. So it just like saved it to raw. Okay, so it would be interesting to try to now load that data somehow. Maybe the way we're going to be loading this data, we're going to be loading this data as assets, right? So why not, honestly? Why not? Like when at the phase of loading the assets for the plugins, we can just load that thing there. Makes sense to me, right? To be fair, right? So, but we have to reuse the same sort of path, so it makes sense to maybe factor out that path to some sort of a constant, right? So let's say nodes bin path, right? Nodes bin path, and plug, not really plug reset that load assets. So in Raylib, so export load file data, that's what we want to have in here, load file data. So we're going to be loading that thing, node bin path, and we actually have to give the pointer to the variable that is going to return the size of the data that we loaded. Okay, so let's create data size like this, and we're going to pass it as a pointer, and we get the data as a sequence of bytes. Fascinating. Right, I suppose it may fail, and in case of failure, it will return null. It's not really explicitly stated anywhere in here, but that makes sense. For example, when the file does not exist, I would expect this data to actually return null. So if data is available, right? So one problem that we may have when we read the data successfully is that the data size is not going to be equal to size of nodes, and that will happen when maybe the schema have changed. Maybe we decided to change the type of the nodes or the amount of nodes or something like that, and in that case, like, we probably don't want to copy that data into the nodes, right? So because it's not a valid data, so we have to first check that the data size that we read is equal to the size of the nodes, and then only then we have to mem copy that freaking data into the nodes, right? So that makes sense to me. Otherwise, we shouldn't even try to do that. So, but what should we do? So we can at least log that. We can say trace log warning, and we can say an expected data size, an expected size of S, right? So, and S is the nodes bin file, We can say expected D, maybe ZU, well, let's say D, and expected is going to be size of P nodes, but got D. And what we got in here is located within the data size thing. Right, so we could have put an assert in here, but assert will kill the application. I don't want this entire thing to kill the application. So because of that, I'm gonna just do a warning. But to be fair, it's not really a warning, it's a straight up error. Right, so it's a straight up error. So in that case, it makes sense. All right, so I'm gonna try to recompile this entire thing and go to the compilation errors. Okay, so there's no compilation errors. So one thing I wanna try to do now, I wanna kill the application. I wanna restart the application and make sure that it loads the things from the assets correctly. It didn't do shit, honestly. It didn't do shit. So, and I think I know why. Because in the plug reset, we actually set these nodes to something. Like, let's not do that. Right, so let's try to run this thing one more time. Will it no, it didn't. Did I not recompile? Excuse me? Wait, what? Am I going crazy, chat? I think I am going crazy. Okay. And it restored the state of the nodes in here. Look at that. It actually restored them. So now I can modify them and I can save them and they will actually persist between the runs and stuff like that. So I just developed a tool that will help us to like sort of label or mark up the area that we have to now analyze. Now need to analyze. So yeah. So I think I want to make a small break because I'm already streaming for like 1 hour. Right, I want to make a cup of tea. And after we made a cup of tea, what we're going to do, we're going to try to develop an algorithm that will allow us to pinpoint the centers of the grids. Right, so we're going to be just using linear interpolation. This algorithm is not particularly difficult to implement, right? But we'll need to implement that to denote like where all of these things are located. All right, so let's make some break and okay, so we have basically 4 points. The question is how we're going to be actually, you know, accessing cells by those points and stuff like that. So I have the following idea. Let me actually start my paint. Let me start my paint. I'm going to put the notebooks in there. I don't really have that much space for the notebooks, but I mean, whatever. Let me also turn on my tablet and let's go. So let's imagine that you have a bunch of nodes, right? So, and the nodes are not really aligned, axis aligned or anything like that. They are all over the place, right? They are in fact all over the place. And this is the first one, this is the second one, this is the third one, and this is the fourth one. So, and obviously they're connected in some way. Might as well just use this sort of pen and connect things properly. And yusu. So imagine that we have some sort of like a normalized coordinates, right? Let's take our area of interest. I think on a break somebody called that area, right, area of interest. I really like this name, so I suppose it's sort of like a professional term from computer vision. I'm ignorant and educated enterprise developer, Java enterprise developer. I don't know any fancy terms, but I really like this one, so thank you very much. So let's actually say that this is our area of interest, right? And instead of using the real coordinates, the pixel coordinates, we're going to normalize that area by saying that the left top corner is 0, right? The right one is going to be 1, and the bottom one is going to be 1. So that's basically our coordinates, normalized coordinates. And we want to use normalized coordinates because they help us to actually linearly interpolate things easier. So now let's say we're interested in some point within the area of interest, right? So, and we know the x of that point, the x of this thing, and we know the y of that thing. So we have x and y. So, and that x and y is between 0 and 1. So what we want to do first, we want to take that x and lerp it on that line, right? We lerp it on that line somewhere, so we get the point here. And then again, we take that X and we lerp it on the bottom line somewhere here, like this. There we go. And we got another line, right? We got another line. And then we take Y and we lerp it on that line in here. And we basically mapped a point in normalized coordinates to the point in this very much skewed coordinate system. And if we want to iterate the cells, we just iterate them in normalized coordinates, constantly mapping them like that. And in reality, we're going to be actually iterating it like this. Very simple, very straightforward. And I really want to try this idea. Right, and I think it's going to work, right? So it's just like these 4 points denote the warpiness of the whole area. And we use them to sort of map these normalized coordinates to the warped coordinates. So this is a very cool idea, I think, my friend. This is a very cool idea. So you only need 3 points, but the 4 will work too, probably. Yeah, I can see that. I guess I can see that, but I mean, it's fine. It's fine. So that's basically the idea that we have in here. So, and to actually iterate the cells, we need to kind of know how many of the cells we have, right? So I already counted them before the stream. So let me maybe start the application itself, right? So I think I even wrote that stuff down. Yeah, so you have 20, can you see that, by the way? I have 22 rows, and you can't really see that, but it's actually 18 columns, right? So 22 rows and 18 columns, right? Once you know the amount of rows and the amount of columns, you can basically divide the normalized coordinates into cells, and you can actually iterate discrete cells like that, right? So let's go ahead and just maybe denote the amount of rows and the amount of columns, right? So grid rows, we have 22 rows and 18 columns. 18 columns, right? And the fact that 18 is actually divisible by 6 kind of confirms that I was going for 6-bit numbers in here. You can clearly see, so this is like this hanging sort of tail, 1 to 3, 1 to 3, so there's a 6 bits in here, so that's why it's like sort of overhanging, right? So it basically confirms that. So as we're rendering all of the nodes and stuff like that, what I want to try to do, I want to just go ahead and start iterating rows and columns in here, right? So it's gonna be row less than grid rows, like so, and then we're internally iterating the columns. So we're iterating first rows, and then we're iterating the columns. Calls, and then calls. So we are iterating within normalized coordinates, right? So that means the coordinates are from 0 to 1. So we need to divide 1 by rows and then 1 by columns. So we need to have something like cell width, which is basically 1 divided by the amount of columns, right? So grid columns, like this. And a cell height is going to be rows, right? So this is a cell width and cell height. So now we want to find x and y within the normalized coordinates, right? So it's going to be column multiplied by cell width, right? So this is x in normalized coordinates, and this is a row, which is height, right? So we essentially found this x and y of a specific cell, right? So now we need to map it accordingly, right? So we need to map it accordingly. So let's take a look at the array math. I'm pretty sure we have something like a vector2 lerp. Yeah, we do in fact have a vector2 lerp. So what I can do in here, so first I'm lerping the top line in there, right? So it's going to be nodes 0, p, nodes 1, and I'm just using x, right? So this is just x, and let's save this entire thing to maybe v1 Zulu, right? So then we're gonna have v2, which is from 2 to 3, Right, and there we go, we have V1 and V2. So after that, we're going to be lerping from V1 and V2 using Y, and that's the final point, right? That's the final point that we have in here, and that's basically the left top corner of the cell of the grid. We can now try to maybe draw a circle there. All right, so let's actually draw a circle at that specific place. So the radius is going to be, let's say, 3, and the color is going to be maybe something like blue, maybe magenta, right? So let's actually use magenta because the pen in here, as you can see, it's also blue, so I think it's going to be very difficult to see like the blue thing. So this has to be V actually. All right, so let's try to rebuild this entire thing, and that got rebuilt. Yeah, that kind of worked, but at the same time it didn't, right? So this stuff is supposed to be, yeah, it's supposed to be something like this, but at the same time, yeah. Let's try. Oh, I think I know, because this thing kind of overhangs a little bit, so maybe what we want to do, yeah, this is probably what we want to do. We want to actually extend this entire, so what's cool is that we can actually adjust things around as we want. Maybe it would be also good to not use the left top corner, right, so the left top corner, and just use the center. So we can quite easily add the center by adding half of the width and height. Right, so it's going to cell height like so. So it's going to render those things at the center of the cell, which in my opinion makes a little bit more sense. Right, so we're going to do that. So yeah. So I'm also going to save this entire thing. So, and this one is rather interesting. So I feel like we'll have to, it's not perfect, right? It's not perfect, but we can always make another screenshot, if you know what I mean, right? So if this is like too much warped, we can maybe do something else about that, but maybe not. Maybe we can just like keep messing with this thing until like it's all right. But it doesn't feel, yeah, I think that's something like that is all right. So this part is not really good. So this is the all right. So let's actually maybe make another screenshot, right? So because this feels a little bit too much warped. Looks close enough. The paper always like to have a slightly curved, so it will drift in areas. Oh, so people do kind of similar things, actually, right? So people do similar things. But we can do another screenshot. It's not really that hard to do for us, I think. So can I do that? So just a sec and screenshot. So I think it was fine. So this is so cool. Thank you. I also think it's cool. Obviously the grid in the textbook is not correctly aligned. Yeah, exactly. So it's not my fault, right? So it's a fault of the notebook. Is this one better? Maybe this one is better. So we are going to just move this thing in here, right? And I'm going to go to secret, screenshot, screenshot. I'm going to just put it like that, and I'm going to say, okay, use a different screenshot in here. And let's recompile this entire stuff. Like so. Okay, now what I can do, I can probably align this thing, then this thing, which goes somewhere here. Yeah, that's kind of bizarre that it's not centered properly at all, but maybe that's fine. Okay, so 3, goes somewhere here, and then 4 goes somewhere here. That's even worse, honestly. That's even worse. Yeah, let's actually go back to the previous one. Let's go back to the previous one. And yeah, so let's work with this one. Let's work with this one. Maybe we can figure out something in here. Okay, so I feel like we need to now apply some sort of a filters to the image. And I'm thinking to use the filters that we developed in Sim Carving stream. Do you guys remember this one? So let me find Sim Carving. So we used 2 filters in there. The first one would create black and white image, right? And the second one is a Sobel operator that will basically detect the edges and stuff like that, right? So I'm gonna copy paste this entire thing in here. And so for the description, right, I'm going to put that in the description as well. It was actually pretty cool stream. It was a series of streams. I think there was 2 streams in there, right? So I'm going to put the maybe playlist. So Sim Carving playlist to be done. There we go. Okay, so now what we need to do. So I think I have Sim Carving source code in here somewhere. Let me see. So I think it was something like a lumen. Yeah, so all right, so there is this thing. There is the function that accepts RGB. It accepts RGB and it basically turns it into luminance, right? So, and we kind of need this function if we want to make the image black and white. So let me copy paste this entire thing. Right, so in the Sim Carving, we were not using Raylib, right? But here we do use Raylib, and in Raylib we have like a actual color in here, right? So, and what we're doing in here, we're basically normalizing the color. But as far as I know, Raylib has a normalization, normalize. Yeah, color normalize. Well, we can just use that. Right, so we can just say, okay, RGB, but I would like to prefer to call it color. I think it makes a little bit more sense. So this is a vector. Which vector it is? It's a vector 4, right? So this is a normalized color. So essentially it just makes it go from 0 to 1, right? So we normalize this entire thing. We don't need that anymore. And in here, we're just like multiplying these components by some sort of coefficients, right? So which basically makes it just like a value from 0 to 1, right? So it actually very much depends. If all of these components, they are from 0 to 1, so in case of all of them being equal to 1, the final result is going to be just the sum of these 3 components. Do they sum up to 1? Okay, they do in fact sum up to 1. So the luminance is not going to be like outside of the range of 0 to 1, right? So it's probably going to be something like this. But we need to do that on the whole image, right? So we have a function that just does that. Luminance. Oh, and this one is rather interesting. So it's iterating through a custom image, right? We probably want to use the Raylib one, and it actually saves that into a matrix, which is an n.h style matrix. Okay, so interesting. Do we want to like extract it somehow? I feel like we need to copy paste this matrix code to our application now. I think we need to actually copy paste it. Right, so yeah, we have, it's not really that much, right? So we can just copy paste the matrix definition, mat add macro, and mat a log thing that just allocates the you know, the memory for the matrix. So yeah, so I'll just copy paste all of that stuff in here. Right, so and in here we gonna copy paste the luminance function, which accepts the image and just turns it into the matrix. Right, so here is the image and here is the image. Okay, so obviously all of that is not going to compile, so let's actually go through the compilation errors and see how it's going to go. Right, so yeah, we're checking that the image has the same size as the matrix. That is absolutely reasonable, right? So otherwise we're going to assert that it's not going to work. So image, yeah, we're extracting the pixel from the image, which is rather interesting. So if you take a look at the ray leap and you take a look at the definition of the image, you can't really directly access the pixels or anything like that. You can't directly access the pixels. So what you want to probably do, you want to take its data, right, image data, and just cast it to a pointer to the caller. So this is how it's usually done in Rayleap. You just take the data, and data is void because, okay, so it may have different formats and shit. So, and if I take a look at the pixel format, I wonder, yeah, so you can have different formats. So when I'm loading an image, is it in the 32-bit format? That's a good question. I don't really know. Maybe it's automatically, it doesn't really matter. So and in here, when I want to do image this, I probably want to do actually pixels, y multiplied by, does the image have some sort of a stride? It doesn't. Okay, so that's very interesting. So this is image width plus x, right? So this is what we want to do. All right, so let's actually try to compile that stuff now and see where exactly it fails. All right, so that worked out. That's literally it. So, okay, what I want to do within the plugin, so we have image, texture, and stuff like that. I kind of want to just have a matrix for the luminance. All right, so this is going to be lum matrix. And when I'm loading the assets, right, look, I'm loading the assets, I loaded the image, and then I converted it into texture. So before doing that, I want to do the luminance analysis, right? So what does it accept as the first? It accepts the image, so I'm going to pass the image, and then I'm going to pass the luminance, right? So, but before I do that, I think I want to allocate enough memory for the matrix, right? So that's what I need to do in here. So width and height, we can get the width and height from the image. So image width and height. All right, so let me try to do that. And so matrix unknown, because I actually defined it below the plugin. C, thank you so much for being C in 2024. Right, so what else do we have in here? Let's actually hot reload this, and it's segfaulted. So I suppose maybe the format is not what I think it is, right? So can I just like pixel, maybe like a format? So pixel format. Okay, so convert image data into design. Okay, this is actually pretty cool. This is probably what we want in here. When we load the assets, right? So we loaded the image, we provide the image. And so what kind of formats can we have in here? Pixel format. So I need just, 32-bit. So it can be compressed even. I think this is the one that I want in here, honestly. This is the one that can be easily cast to caller structure, if I'm not mistaken. I think that's the right one. All right. Cool. Does not compile. So we have to pass it as a pointer. Okay. So let's actually try to run it. And okay, so that seems to be working. But I mean, it's not black and white, as you can see, right? It is not black and white, but it's fine. So now what we have to do, we have to iterate through luminance in here and kind of like feed it back into the image. Right, so to modify the appearance of the image. So let's actually do y less than luminance height, something like that, and then this is going to be something like x width x, right? So I'm just iterating through all the pixels, and I can actually kind of take the thing. So mat at, let me take a look at the definition. So here we get the row, that means this is x p luminance, and honestly, how can I construct a color out of that? Can I use color from HSV? Right. So essentially, hue doesn't matter. I'm going to put 0 in here. Saturation is going to be also 0. There's no color involved in here. I suppose I can just plug luminance into value, and that's basically going to be the desired color. So let's actually have something like a color pixels, which is going to be p image data, right? So in its incorrect format, as we know already, right? So because we converted it. And now I can do pixels y multiplied by the p image width plus x, and I just assign this thing in here. So I basically feed it back into itself, and after feeding it back into itself, I'm creating a texture out of that so I can render it. So hopefully after all of these manipulations, it's going to be black and white, or grayscale, right? So it's not really black and white, it's more like a grayscale. Okay, so the comparison, blah, blah, blah. So it doesn't like that these things are unsigned. Let's make them signed. Doesn't really matter, honestly. Doesn't really matter. So are you going to be happy? So we also have unused colors. Like, why do we even have them? So let's actually remove that. Kind of annoying warning. Okay, so let's take a look. Yeah, so now it's grayscale. Look at that. It's grayscale. That's pretty cool. Yeah. So can we now apply the Sobel operator? So let me take a look at how you do the Sobel operator. Sobel operator. So you have a Sobel filter, but it's applied. Okay, so let's just copy paste this entire thing. All right, so luminance, I'm sorry. Right, so, and Sobel filter is just like a couple of kernels, right? So for X and Y and stuff like that, and we just like apply them, right? So it's a convolution, right? So it's a usual convolution. Right. Okay, so it seems to be working, seems to be twerking. Oh, it's only for a specific pixel, like CX and CY. Okay, that's fine. So I think, yeah, so there is a variant which does the other thing. So, but this one accepts. Damn, it doesn't do that in place? Really? Yeah, okay, that makes sense. Because since it's a kernel, right, so it's a convolution, it depends on the neighbors. Because of that, you can't really easily do that in place, right? So you have to do that into a different buffer. Right. So because otherwise you're gonna be messing up with the neighbors, and they're gonna be messing up with the rest of the stuff. So that makes sense. Okay. So we need to have a separate grad in here, right? Might as well even maybe do it like that because it's C. Who said? I mean, I'm not sure if it's going to be doing that correctly in the memory, but that's fine. Anyway, so load the assets, right? So we're loading the assets. So we did the luminance, and then I probably want to allocate. Might as well actually copy paste this entire thing, right? So I'm doing that grad, and then Sobel filter, right? So I'm just saying that I'm taking the luminance and I'm turning it into the grad. So, and after that, I'm feeding back not really the luminance, I'm feeding back the grad thing, right? Might as well actually inline this entire stuff like so. So let's actually use image instead, so it's a little bit more neutral to the filter that we're using. And here we're gonna just say it's a grad. Okay, so let's actually try to recompile this entire thing. It seems to be compiling. Let's hot reload. It's taking some time, and now we have edges and stuff like that. Okay, so yeah, so now we can do some interesting stuff. Now we can do a very interesting stuff. We can maybe, oh, this one is going to be recognized as one, right? So essentially we can just sample around these centers. Right, we can sample around the centers and just take the sum. And if the sum exceeds some sort of a threshold, we're gonna claim that this thing is sort of like 0 or 1. Right, so 0 or 1. So that's pretty cool. So yeah, it's actually kind of cool. People said it was so fast. Well, I mean, it's not really that big of an image. And there was a delay between actually hot reloading and like actually displaying this entire thing. I can go back into, like, let's actually disable the feeding back. Where is the secret? So I'm gonna just disable the whole thing and I'm gonna recompile. Okay. Yeah, there we go. And now I'm gonna bring it back like so. So to actually get an estimate how fast it is, I'm hot reloading. So I wouldn't say that fast. So there was a little bit of a delay between, like, you know, me pressing H and hot reloading this entire thing. Right. So yeah, I don't think it's that fast. So I'm a little bit worried that they kind of skewed in here, so I'm not really sure what exactly to do with them in here. But it's kind of... so this is third one. This is the second one. All right, but it's probably fine. So yeah, so somebody in the chat said that they quite often people do a little bit of a curving in here. Yeah, the paper seems to be curved. Yeah, so that's kind of the problem in here. The paper seems to be curved a little bit, but I'm not sure how exactly to get rid of that. But maybe it's not even curve of the paper. It could be warping of the camera as well, because it's not really curving that much. It's actually sitting here pretty straight. So I wouldn't say that, but maybe it's not really that important, honestly. Maybe it's not that important. We can just like sample around that single center, right? So, and you know, yeah, just and just like see if we can figure out the threshold, right, which is going to be reliable enough. Anyways, so let me try the following thing. So when I press some sort of a key, is the key pressed? So which key do I want to use? Let's say it's going to be something like P. Right? Do I use P anywhere in here? Do I use P? I don't think so. So let me now try to iterate through all of these things. So this is going to be the iteration. I don't really want to display anything in here, though maybe I should have actually displayed something in here. Right, so yes. So here's that. Then we figured out this thing. You know what? Maybe I should factor this out to a separate function. Right. Maybe I should factor it out to a separate function. So essentially it's going to be vector2 foo, and it accepts maybe float x and float y. So map coordinate, map point. Let's call it map point. And I'm going to just take this entire thing and put it in here. So, and what we are returning, we're just returning the third lerp in here, right? So I think it makes sense to do it like that. So in here I can just do map point x and y. So interestingly, what I want to do, right? So I want to do a little bit of a Monte Carlo around that center specifically, right? Some sort of a Monte Carlo situation. So let me see. What I'm thinking is that okay, so I have some, okay, come on, you can do that. I have some sort of a cell that looks like this. Right, so I have some sort of a cell. So, and maybe I can just have this area around that point, and the distance in here is basically quarter of the width and height. So that's basically the idea in here. I'm calling it now, it's just gonna be a your mom or Disney style. I don't really know what it is there, honestly. I don't really know what it is because it was so long time ago, right? It could be anything actually. So companion cube, yeah. Companion cube. All right, so I probably want to just do like a couple of samples, right? So let's do size t, and I'm gonna say this is gonna be maybe, let's say 5 samples, right? So this is gonna be 5 samples, and we're gonna be just like sampling them randomly, and we're gonna be collecting the sum. Right, so this is gonna be the sum. So I need a random value from 0 to 1. Can I actually grab, do I have rand float? I don't really have a rand float in here. Well, I didn't really need random float in sim carving. So maybe I can steal some stuff from nn.h, right? So nn.h is my neural network framework that I started to develop some time ago, and it's kind of paused. Right, so it's not abandoned. I never abandoned my project. I just paused them because I have too many projects to work on, right? So I may go back to that at some point, right? So for people who are interested, I'm gonna put that in the description as well, right? And I wonder if I can just take the like a random float from there. Rand float, yeah, okay, so I do have rand float, and it's pretty straightforward, right? I would just take rand and divide it by rand max. Okay, so this is the secret, and let's put it somewhere here, right? So it's going to be extremely useful. So because now I can just take rand float, and this is a value from 0 to 1, and since the distance in here is a quarter, the size of the side of this inner sort of thing is actually half of the width or half of the height. So I'm going to go with cell width, half of that. Right, and I'm going to just take an X and offsetting it from, yeah, so we can actually do something like this. So let's say that we only care about the left top corner, right? So this is the left top corner. And we're offsetting it by the cell quarter, right? So this is 25. So, and this is basically the position of the sample, and we kind of repeat the same logic for the y, except instead of x is going to be y, instead of width is going to be height, and so on and so forth, right? So there we go, we got the coordinates of the sample. Now we can map the point sx, sy, right? And that's the point that we kind of have in here, right? So I can say vector s. But now we need to access actually a gradient by that point, right? So we can do grad, so it's going to be mat at, so, and first one is a row, so that means it's sy, and this is sx. So, and we want strict, like basically round it to integer in here. And we're just adding that stuff to the sum. Okay, so the next thing I want to do, I probably want to print that sum because I want to see what it is, right? So usually sum prints like a huge amount of things after the period, right? So we probably want to do something like this, right? So, and after that I want to actually print a new line. Okay, so it's going to print all of that to the standard output, and I just want to see the matrix in there, right? We'll see how it goes. We'll see how it goes. Okay, I'm hot reloading this entire thing. I'm opening the logs, and I'm gonna be printing p, and we'll get something. So did I forget to put? Oh, I forgot to put spaces. Okay, so that's all right. One more time. Hot reloading. Opening the logs. Pressing p. Okay. Oof, 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 oof. Empty, empty, empty. Field. 023, 023, 013. 1. Okay, I suppose next one is empty, empty. Filled in. Empty. Oh. It kind of predicts it if we use 1 as a threshold. Okay, we can try to use that. I don't freaking know, mate. Let's increase the amount of samples, right? So let's actually take like 10 samples or something like that. So maybe it's gonna be a little bit more reliable. Okay, so that sounds Gucci. All right, so now if I take a look at this thing and I'm gonna do print, that's a little bit better, I think. So then, so 2, 4. This is actually kind of cool. Can we just like use 1 as a threshold? Or I think it's too much because as you can see, this is 1. So I think it's 2. right? So in this particular case, it's more like a 2 threshold. So now, chat. What if can I do that every frame? Because I don't think adding like 10 iterations, additional 10 iterations in here is too much, honestly. So maybe I can embed that logic in here and actually highlight things that are kind of recognized as the filled-in stuff. So here we do the mapping in here. So it's a map point X and Y, right? So let's actually get rid of this thing. So I think it's going to be kind of interesting. Right. So, and in here, so I might as well actually move those things in here. And we're going to be just like using a different maybe color for them. Right. Hello, YouTube subtitles. Yeah. So everything you write in the chat is going to be in the YouTube subtitles. Yes. Okay. So now let me maybe take this logic in here. And I'm gonna put it in here. So, and this is float sum. So this is quarter. All right. And essentially, if sum is less than 2, actually, let's put it this way: greater or equal than 2. And if it's not, we just don't even render it. How about that? So we just don't even render it. So let's see if it's going to work or not. That's pretty stable, I would say. That is pretty stable, except of some of these places in here. I really like this one at the bottom. Okay, so maybe the amount of samples should be slightly different. I wonder if it's lagging. It's not lagging, but anyway. This one is also kind of bizarre. Maybe threshold should be like lower. Or maybe not. Nah, it's still having a little bit of a trouble. Not bad, looks right on average. Yeah. So it's like definitely like figures out these kind of things. Right, it definitely figures out these kind of things. One of the things we can do, maybe we can do that several times, right? So we can do several random passes. But that just means like we need more samples and higher threshold. So we just need more samples and higher threshold. Oh yeah, it's start to actually go to, yeah. All right, so let me see what we can do. So why use Sobel instead of Gaussian? Because that's the only thing I know, and that's the only thing that was actually available ready in my code. So that kind of makes sense, I think. Sobel might not be great in here. I don't know, like it's just like whatever was lying around here already. So, and that's what I used in here, but I guess it's fine. So what else do I need to do? I want to now increase the amount of samples, but if I increase the amount of samples, I need to also, I want to reduce the radius. Kind of want to reduce the radius. Because maybe quarter is actually kind of too much. So let's say we're gonna have 20 samples in here, and the thing in here. So we can say that we're starting at this stuff, then we are mapping maybe 25, but then what we have to do, we have to subtract. So this is not particularly convenient, honestly, right? So this just gives us the length, right? But then we have to subtract half of that, so to speak, right? So we have to subtract half of that. Right, so it's gonna be 0.5. Maybe we can factor out this thing as some sort of like an area, right? So this is more like an area, which is 25. Emacs, come on. Okay, so this is 25. And now this is an area. Yeah, that makes more sense. I think that was a better idea. So I just narrowed down the area within where we're sampling things, and I also increased the amount of samples. Like hopefully that will give us more predictable results. Right, so I'm gonna hot reload this entire thing, and I'm gonna press P. And if I take a look at the logs now, so yeah. So is that the correct logs? Yeah, look at that. Okay, so they're more like 8 now, if you look at them, right? They're more like 8. So, or maybe sometimes even 7. So let's use that logic now, right? So we're gonna be using that logic now. In the rendering here as well. Right, so it's probably going to be a little bit slower, but now the threshold is 7. The threshold is going to be 7. Okay, so this is going to be compilation. And let me hot reload this entire thing. And is it going to... it's kind of working, but I feel like the threshold... Let's reduce the threshold to maybe 6 and 5. Right, so 6 and 5. Compilation. Alright. Alright, so let's hot reload this entire thing. What about maybe even 5? 5 and 5. Alright. It's pretty reliable in some cases. It is pretty reliable in some cases, but not 100%. Right, not 100%. What I'm thinking is that maybe I need to actually create a buffer where I'm gonna be, where I'm gonna be storing the bits, and if I need to, I should be able to correct them manually. I think that's what I need to do, chat. Right, so, okay, so here is an idea. So when I press P, maybe change the threshold with the key press while running. Yeah, so this is something that I can do, but I mean, it's hot reloaded anyway. So here's the idea I have. I'm gonna create an array, right, so of 22 by 18. When I press P, it's gonna basically make an estimate. It's gonna make an estimate and just put some stuff on the screen. And then later I should be able to correct them by pressing on them and say, okay, this is actually filled in and stuff like that. Right, so this is basically the idea that I have. Right, but I'm already streaming for 2 hours and I want to make a break and I want to make another cup of tea, right? So because it's a very intense, I'm doing a very difficult, intellectual work in here. It's a computer vision, it's artificial intelligence, it's machine learning, big data, and the Internet of Things. Right, I'm making the future in here. So I need to make a break and I need to caffeinate myself. Right, so let's make a break and all right, so I want to make another screenshot of the whole thing. So some people suggested to maybe keep it a little bit far away, so to reduce the amount of warping that is going on in this entire thing. So I'm gonna try to do that. I'm not sure if it's going to help, but why not? So let's give it a try. So here's another screenshot. Is it a good? Well, I mean, we can probably extract some information out of here, right? So it's kind of weird, all right, but that's fine. All right. So what is it called? I forgot the name of my project. It's Panim. Panim. Assets, images, let's go. So I'm gonna move this stuff in here, and that's the new thing. So secret, right, so load assets. So this is going to be that, and I'm copy pasting that, and then I'm just taking this entire thing. Okay, so that's cool. So let's rebuild it. Did I need to rebuild? I didn't think so. All right. That is pretty cool. So, oh, that made it worse, honestly. That actually made it worse, surprisingly. So yeah, that is not particularly helpful. So if I just place this thing in here, this is the second one, this is the third one, and the fourth one is around here. So that is definitely makes this filter not correct, if you know what I mean, right? So that means maybe that's not the filter we want to use then, right? So that's probably not the filter we want to use. If I just use the black and white, the black and white filter might be a little bit better, though. Actually, the black and white filter might be a little bit better because in this case, the sum is going to be smaller, I think. Right, I think the sum could be actually smaller. All right, so now if I go to here and I kind of get rid of this entire idea, right, so I can see and adjust the things in here. So up the contrast, yeah, so something like up in the contrast could be useful. That is true. I do agree with that. So these things are aligned a little bit better, I think, now. If you ask me. Yeah, that's aligned much better. Look at that. So I think actually that helped. That's much better already. So this one is if we're gonna be rendering the nodes. Where is the rendering of the nodes? I don't see. So there was a node radius. Node radius, let's say, is gonna be something like 3 because I want it to be visible. Oh fuck, I fucked it up again. So I keep forgetting to save the grid, right? So that's kind of a huge problem for me. I implemented the saving of the grid, but I forget to do that all the time. Right, so I'm gonna save it right now. That is perfect, right? So this aligned really well, I think. What do you guys think? So increasing the contrast would have been actually very good for this stuff. Is this a QR scanner? Almost. So I can try to do what? I can try to do the sum just right away and see how it's gonna go. So we're gonna do 20 of these things. The area is gonna be rather small. Yeah, let's just go ahead and do that. So I already have that. I'm gonna press P. Let's take a look at the, you know, this is sus. This doesn't look. Wait, what the fuck is that? Oh, because it's using the grad. Fuck me. All right. So you need to use luminance. Right, so now I would expect the filled-in ones to have smaller value. That's what I would expect them to have. So yeah, so that makes sense. Look at that. So 18, 18, 18, 10, 18, 17. All right. So is that a good amount of these things? So so Majesef, thank you so much for the subscription, and everyone who subscribed before. Zanio Lanio, thank you so much. Veristachev, thank you so much. Thank you. Right, 65 months is pretty crazy. Yeah, 65 months is pretty crazy. So the big value, so 10 is filled in, right? So that means it is smaller. What I'm thinking is that let's reduce the radius even more, right? Let's actually take maybe 10. The fuck just happened? 10%. What about 10%? I think that could be a thing. So I'm gonna hot reload this entire thing. I'm gonna press P, right, and in here, okay. So the filled-in ones, they're like, they have 16. Do we have like 50? Sometimes some of them do have 50, right? And if we take a look at that one, So do you have 14? So now we probably need to kind of adjust some of these things. Kind of need to adjust all the things. What about 8? Maybe even more simple, but not really. All right. Yeah. So some of them are 15. Yeah, this one is 15. Yeah, I think that is good enough. That is good enough. Let's give it a try. So, and we'll see if it's like performing better. So where is the sum? So I'm gonna copy paste this thing in here. So the sum goes here. So maybe I need to factor out this repeating piece of code, but anyway. So it's filled in when the sum is actually less than 50. That's gonna be our threshold in here. Let's go. So it's pretty close. Reduce the threshold. Actually increase the threshold? I think we need to be increasing the threshold. It is rather stable, honestly. It's kind of cool how stable it is. So I don't really like magenta. What if I make it red? Yeah, that's much better. Sometimes it just like, yeah, so there's false positive and stuff like that. It doesn't recognize this one, unfortunately. Even though it should, I think. Oh shit. So it has to be more like this. So this thing, like, it's actually not bad, honestly, yeah, right? So whatever we have right now is not bad. So the question is, what a better filter we could use? That's so fast. I mean, it's okay, I guess. I don't know. That's too much. That's for sure. That's for sure. Wait a freaking... What the fuck is this shit? I copy-pasted some stuff and I'm an idiot. Okay, just a second. I had a bug in here. Had a nasty bug. Holy fuck, it's on point. What the fuck? We achieved AGI internally. What the hell? Holy shit, it's so on point. What the fuck? Skynet. Yo, I didn't expect to be... This is so fucking perfect. Yep. We can just go ahead and decode it, motherfucker. Alright, let's go ahead. So we have all of the necessary parameters and shit. Yesu, kawaii freaking desu. So how can we even do that? When I press P, right. When I press P, I want to actually factor out these parameters in here. So this is going to be samples, right? So this is a sample count, right? Let's put it like sample count. Sample count is going to be 20. Where is the second 20 in here? And this one is going to be sample area. I want to factor out that thing to also a constant. So this is going to be a sample area. Блядь. Sorry. All right. So also we need some sort of a thresholds as well. So sample area. Блядь. Kurwa, блядь, сука. Я пердоле нахуй. It's fucking piece of art, honestly. It's just like amalgamating Russian and Polish swear words. Kurwa, сука, блядь. Anyways. To be fair, I feel like this is something that I heard from some Ukrainians online, mixing up like Polish swear words and Russian swear words. Yeah. All right. So also, we need to have like a sampling threshold as well. Sample threshold. Like, can anybody explain me how the fuck we came up with this pronunciation of this word? So, threshold, where is the h? Like, why this sh is read like sh? Can anybody explain to me like how that happened? Or maybe I misspelled something, I don't freaking know. So, threshold. Did I even spell it correctly? I'm actually not sure. Glitched out, thank you so much for the subscription. Thank you. Threshold. Again. Okay. Threshold. Whatever. So what was the threshold? I don't remember. The threshold was 15. I think I just spelled it incorrectly. Maybe. Sample threshold. Where is another 15? I don't see another 15. Because I never actually use it anymore. Whatever. Okay, so chat. Now this is very important. I need to actually iterate them from left to right, but I need to iterate like by 6 columns, right? I need to be iterating by 6 columns. So that means I need to have something like bits count. So something like this. So bits count, key P. So what I'm going to be iterating in here, honestly, I'm going to be iterating maybe like a bit call from 0 to less. So I take the whole amount of columns and I divide it by the bits count. So then I take bit column, right, so and increment it. Okay, so I'm actually iterating from left to right these bit columns. Within this thing, I'm iterating the whole stuff. Row from zero, row less than grid rows, like this. And then within that single row, I'm iterating a single bit. So bit 0, bit less than bits count, like so. Right, so essentially I'm going to be iterating this group of bits, then this group of bits, then this group of bits, this group of bits, until the end in here. Then I'm gonna go here like so, and then here like so. Right, makes sense. I think it makes sense. Okay, that's cool. So how are we gonna be going about that? So I need to actually maybe factor out. I actually need to factor out this entire function that sort of like a sample cells. Right, so let's actually go ahead and do that. Float sample cell, and what I have to provide in here, I can actually provide row and column. Right, so which will basically just sample that specific cell. That makes sense, I think. Right, and yeah, that's basically what we can put in here. So sample the cell. So, and after that, I just return the sum. Can I recompile this entire thing? Let's go to the compilation error. So cell width. Cell width is very straightforward. So it is basically that. We can put it in here. What else do we have in here? Okay, so that's pretty cool. So then, what I can do, I essentially can sample cell, right, sample cell, but I have to provide first row. I think it accepts the rows first, yeah. And then the column. But the column is bit column multiplied by bits count and offset by a bit. So, and if this entire thing is greater than the sample threshold, right, so that means this is a positive bit. Okay, we can even just save it as a value, like so. And what we can do essentially in here, so so for that single row, so this is just a single bit. So maybe I should call it offset. So then I can call it a bit, and here this is a value. It's initially 0. And how we're going to be collecting all of these things? We're going to be collecting them probably like this. So value, move to the right, and I'm just like collecting that specific bit. And maybe then I can just printf that value. I can just printf that value like so. So we don't really need any of that stuff anymore. I think, right, when I press P, I just do that. So I will also want to tuck away this sampling process as well. Right, so I can do sample cell, row, and column. So that makes it a little bit easier for us, right? So it's, was it, wait, what was it? Was it greater than threshold or less than threshold? I don't freaking remember. It was less than threshold, so that's kind of important. So sample cell, row, column, less than sample threshold. Yeah, it's less than that, so that's kind of important. That's kind of important. Right, so let me try to recompile this entire thing. So it's is it bits count? I think it's a bits count. All right, so okay. There we go. So we've got a spammer in here. Okay. So now I'm going to go into the logs. I'm going to press P. All right. So it kind of extracted. Okay. So that's cool. That is not really. Why the first one is 0? Doesn't make any sense. Am I going crazy? So the first one is not supposed to be 0. Bit and offset. Bit and offset. Okay, I see. That makes sense. Thank you so much. I'm already getting a little bit tired, so thank you for helping me. 42 suspiciously, yeah. All right, so I'm gonna press P and oof, 4. Okay, so let's actually don't print it as this thing. Oof. To be fair, the fact that it's 4, it doesn't look like ASCII at all. the question is, here's the interesting question. 6 bits. ASCII is 7 bits. So 1 bit was omitted. For whatever freaking reason. What is that bit? Backwards? No, no, even if you look at that. So here, this one is not ASCII, even if you like read it backwards. This is not ASCII. I think 1 bit was omitted. I think 1 bit was literally omitted. So what we have to do in here, I think, let's actually start with maybe something like 1. First 5 rows. No, I think it was 6. Honestly, I think it was 6. Okay. At least they look like ASCII. At least they look like ASCII. Okay, so what if we revert them? So let's start with. Can I do that? Greater than 0. Is it going to? Is it going to do the offset right? So I feel like we have to do something like this, and because of that, this has to be an integer. So because it needs to go negative. Okay. Hello world. Hello world. I can keep my secret message here. Wait, what the fuck? Let's like, what the? Okay. I think, like, well, what's funny is that I don't remember. It was so fucking long time ago. I don't remember doing any of that stuff. Okay, so just a second. So there's some errors in there. So I don't know how I was deciding how to. Okay, so there's some sort of a flushing problem going on. Just a second. I probably need to put a new line in here. I'm gonna refresh that. Wait a little bit. Print P. Oh my god! Wait, what the fuck is going on? Just a second. Wait, what? Oh, I see. Okay, I should. I put a new line outside of the condition, so it was actually printing a new line on each frame. Holy shit. Okay, so just a second. I hope I didn't. All right. So everything's fine. I'm gonna press P, and hello worlda. Hello worlda. I can keep my secret messages here. N. So yeah, I'm not really sure how exactly I decide the. Yeah. I'm not sure about the world in here, but it works. Hello? So that's kind of bizarre. But I mean, it worked. Kind of worked. So now it's kind of broken, but now we know what the fuck is going on. So I'm just iterating those things, and I'm just columns. The amount of columns was 18. It's supposed to be 18 and 22. Yeah, it's no longer a secret. It's pretty cool. So yeah. I guess like you can take this code and turn it into a more generalized tool for like decoding messages like that. So that was kind of cool, right? So obviously like these kind of filters that I used are probably not ideal for this entire thing. Is there another message with just the additional letters? No, there was only this thing, right? So for those who just joined, the backstory of this entire thing is that I found in my old stuff, I found this notebook, which apparently I bought 10 years ago, but I never actually used it, right? So it's completely blank, except first 2 pages. And on the first page, I have this kind of thing. And it's something encrypted. And I know that it's something encrypted because this is what I like to do with all of my notebooks, right? So in my other notebook, again, I have my email encoded as base64, right? So because I just like to put like little Easter eggs in all of them, right? So something like this, for instance. So, but I don't remember the specific of this one, right? So, and I just decided to make a stream out of that, right? So decoding this message, so to speak. I could do that manually, but it's freaking boring. So I wrote a program, so I had a little bit of exercise, and yeah, there you go. So, self-doxed. I mean, my email is actually public, so everybody knows that. So yeah, that's cool. That's really cool. I don't really know why I put this message in here. Like, I did all of that manually. Like, I sat down and actually like draw this entire thing. Like, what the fuck is wrong with me? What the fuck is wrong with me? But yeah, anyway, so that was fun. And it kind of demonstrated that Panim is actually useful. It's more than just animation framework. So I can use that for creating these small little tools, which are very useful when you want to iteratively like develop things. So that's pretty cool. So yeah, that was fun. I guess that's it for today. Thanks everyone who's watching me right now. I really appreciate that. Have a good one, and I see you all on the next recreational programming session with Mr. Azuzin. I love you.